All right, welcome to Algebra 2, Unit 3, Lesson 2. Okay, this is composite functions and finding domains. So, first of all, a quick review of some symbols in mathematics. An n with two lines over here will stand for natural numbers. Those are the counting numbers. Whole numbers, which would include the 0 and then all the natural numbers. It's got two lines for that W right there. Integers is a z with two lines for the diagonal on that z. Okay. Rational numbers are represented with the variable the q, and the r, the double barred r, stands for all real numbers. Okay. And this right here, this e looking thing right there, okay, that stands for exists as. Okay. So this says in this particular function, okay, the domain is restricted between -2 and 1 for x, which exists as an integer. Okay? So composite functions. Okay, a composite function is a function within a function. Okay, two functions written together as one expression. Okay, so if I've got this, composite functions can be written a couple of ways. It can say g of, that O stands for of f of x. Okay, I can write it like that, or I can write it like this. They mean the exact same thing. Okay, so the innermost one, okay, or the innermost one, or the right number or the right variable tells you which one you plug the information into first. So first plug into the f function, then take your answer and plug into the g function. Okay, on this one right here, you first plug into the g function, and whatever answer you get, you plug into the f function. Again, you plug into the innermost one or the right one first. Okay, so let's go ahead and look at this. Okay? We've got two functions, the f function right here and the g function. Okay, and this is telling us what to start with and which function to plug into first. This says we're going to plug in the number 0 into the f function first. Whatever answer we get, we're going to plug that answer into the g function, and that'll give us our final answer. So I stick in 0 for f, 0 for x in the f function, get the answer of 2. Okay, take that answer, stick it into the g function, right there, get the answer of 6. So I can say f of 0 of g is equal to 6. Okay, let's move this up. Okay, again, this time I'm going to stick the number -2 into g, whatever answer I get, and I'm going to stick that into f. Okay, so I start with the g function. 3 times -2 gives me -6, so g of -2 is -6. Take that -6, plug it into the f function, come out, and I get f of -6 equals -28. And I can say now, I can write it as a complete answer. G of -2 of f equals -28. Sorry, f of g of -2 is -28. Okay, same thing here. Okay, I'm going to stick the 1/5 into the g function first. Okay, the answer then goes into the f function. So g of 1/5 equals 3/5. Okay, f of 3/5 equals 5. Right. So then I can say g of 1/5 of f is 5. Or f of g of 1/5 is 5. Keep getting that mixed up. Okay? You read left to right, but you start from right to left. And simply the same thing this time. We're not sticking in a number into the function, we're sticking a variable in. So I go ahead and stick in the letter a, replace that x with the letter a, and I get a is equal to, well, f of a is equal to 5a plus 2. So I go ahead and stick in 5a plus 2, multiply everything by 3 because that's what the g function tells us to do, and the answer is 15a plus 6. So I can say f of a of g is 15a plus 6. Now for these, it's actually pretty easy. You don't have to do any calculations. You just have to pinpoint on your ordered pairs here where it's come from. So, said, we start from, plug into g first. G of -6. Well, g of -6. So you input -6 into g. Your answer is -1. And I take the -1, plug that into the f function. Well, -1 in the f function is this. The answer is 0. There you go. Okay. Again, stick in 5 into the f function. The answer is 4. Okay, so I stick 4 into the g function now. The answer is 9. So you can write it like that. Okay. Stick in f into the f function. Sorry, stick in 10 into the f function. right there. Answer is 6. Stick in 6 into the g function, the answer is -1. Okay, same thing again. Stick in 3, answer is 7. Now stick the 7 into the f function, the answer is 1/4. You can write it g of 3, then plug that into the f function. Okay. Finding the domain of a function. I'm not going to read this out for you guys, but you should take a moment to read this before you move on to the next page. Okay. We are going, instead of finding all the values of x that do work, okay, we're going to find the x values that do not work, which is usually a much smaller set of numbers. So we're going to go ahead and focus on the x values that violate rules that we know can't work. Okay, so you should take a moment and read all this stuff, and also read this entire next page. Okay, so I would suggest you pause the video for a few minutes, read this stuff, because otherwise I am going to move fast, okay, and it's not going to make much sense. So please take a moment to go ahead and do that. All right, so starting here at the very top, okay, we're looking for values of x that would violate some rules. Well, what's one rule we know about fractions? Well, the first rule we know about fractions is that you cannot have the number 0 on the bottom, because once you have a 0 on the bottom, the entire thing becomes undefined. So, well, we solve. First thing we do, we have an x on the bottom by itself. Well, that x cannot be 0 because 0 times anything this becomes is always 0. So one value that x cannot be is the number 0. Okay. Now that's the outside x. Well, what can the inside x not be? What would make this equal to 0? So I solve this, x minus 3 equal to 0, and I get x equals 3. So the values of x that would violate the rule of having a 0 on the bottom would be 0 and 3. So we can say the domain is all real numbers except 0 and 3. Okay. On this one, we have 2 parentheses. Okay. So we set each parentheses equal to 0. 2x plus 1 equals 0. So x is equal to -1/2. Okay. And I set this one equal to 0 is all. And I get x equals 7. So the two values that would make the bottom of the fraction equal to 0 would be -1/2 or 7. I can put in either one, and that would violate the rule by putting a 0 on the bottom of the fraction. So again, the domain is all real numbers except 7 and -1/2. Okay. Again, it's a fraction, so we know that we cannot have a negative on the bottom of the fraction. So I go ahead and solve this inequality equal to 0. So x, absolute value of x minus 2 is equal to 0. Again, move the -2 over. And then again, I do a drop and op. I write the inside of the absolute value, solve it equal to the positive, and solve it equal to the negative. Well, there's nothing else to do. So x cannot be a 2 or a -2, because that would violate this rule by putting a 0 on the bottom. So again, our domain is all real numbers except the number 2 and -2. Okay. Underneath the square root sign, okay, the number that we cannot have is a negative number. So all negative numbers underneath the square root sign would violate the rule for square roots. Okay. So again, I set the inside of it equal to 0, x equals -4. Now for this one, we're going to have to create a quick little number line. Okay. I put the number -4 in here, and I put one number above and below. So -3 and -4. Sorry, -3 and -5 on either side of the -4. And then I go ahead and plug the -3, which would represent all numbers that are greater than -4, and the -5 would represent all the numbers that are less than -4. Okay. Again, 0. Okay, so let's say if I stick in the number -4, -4 plus 4 is 0, square root of 0 is 0. That actually works, right? So you can say yes next to this. If I stick in the number -5, -5 plus 4, well, that gives me -1. That's a negative answer, and that doesn't work. So we put the number, we would say no. Let's just try the other side. Okay, -3 plus 4. Okay, that's a positive one. That works as well. So -4 and greater works, but all numbers less than -4 do not. So we can say the domain is restricted to all real numbers except x less than -4. Okay. Again, same thing. We cannot have a negative in here. Okay. So I solve the inside of the bracket, inside of the square root bracket, solve it equals 0, and I got x equals 9. Again, I put 9, 1 less than, 1 greater than. And again, I go through the same process. If I put an 8, 8 minus 9, well, that works. That's a positive answer. 9 minus 9, that also works because that's a 0. Well, we can still use that. Okay. If I put in the number 10, 10 won't work because that would give me a negative answer. So 9 and all numbers less than 9 work, but the numbers greater than 9, like 9.1 and greater, don't work. So we can say the domain is restricted to all real numbers except x greater than 9. Okay. Now in this one, we've got a couple things going. We've got the square root, which we say we can't have a negative answer. Okay. And then we've got it's a fraction, so we know it can't also be a 0 at the overall end. Because if we put in 9 here, this one, 9 minus 9 is 0, square root of 0 is 0. That works. But for this one, okay, we solve for 4. So x plus 4 equals 0. We get negative 4. So again, negative 4, negative 3, and 5. This time, negative 5 won't work because that'll give us a negative answer, so that violates the first rule. Okay. Negative 4 won't work because negative 4 minus 4 is 0, square root of 0 is 0. Well, we can't have a 0 on the bottom. Okay. Then we stick in negative 3. Negative 3 plus 4, that gives me a positive 1. Square root of 1 is 1. So this works. So I can put the word yes. So again, this time, the domain is restricted to all real numbers except x less than or equal to, this time, negative 4. Okay. Look at this function here. It's just a regular function. It's actually a linear equation. That means we can go ahead and stick any number we want to into this, so it doesn't matter. So the domain is unrestricted. We can say the domain is all real numbers. Okay. Finally, graphs. Okay. These graphs, students have a hard time with it. So what we want to do on these graphs, okay, we want to find the domain, which is all the x values that are part of this graph, and the range, which is all the y values which go up and down. Okay. So to find the domain, okay, what is the furthest furthest left we go on our graph? Well, the furthest left we go is at negative 4, right? Okay, so I put the number negative 4 there. And how far to the right do we go? We go all the way up to the number 5. Okay, so our domain is going to be between negative 4 and negative 5. So I put negative 4 and negative 5, and since we include the dots, we use the inequality less than or equal to, less than or equal to. So x is between those two numbers. Okay. Now, let's check out the range. The range tells us how far up and down we go. Okay. So again, we say how far down we go. Well, we start off at negative 7. So I put the number negative 7 right there, and I go as high up as positive 6 right there. Okay. This time we don't put the letter x in there because we put the y, because y denotes the range. Okay. Again, y is bounded between these two numbers. X is bounded between these two numbers. Okay. Well, now we've got the domain, we've got the range. Okay. Well, is this a function or a relation? Well, we use our vertical line test. Look at that. I hit 2 points, so this is a relation. Okay. Number 2. Okay. Again, first we find the domain. How far to the left do we start? We start at negative 3. Okay. And then it keeps going. This arrow means it keeps going forever this way. So that means it's never bounded on the right side. So it's all values that are greater. So we know it's negative 3 and then all the way this way. But does it include the number negative 3? Because it's a hollow dot, that means it does not include it. So we use the symbol x greater than negative 3. Okay. Also, now for the range, how far low do we go? How low do we go? Well, we start at negative 4. So I put the number negative 4 there. We know we're talking about y. Okay. And it keeps going on forever. As far out it goes this way, it goes up that way. So again, it doesn't include that number. So we say y is greater than negative 4. Now, we use a vertical line test to test if it's a function or a relation. And look at that. At all points, it never hits more than 1 point. So this is a function. All right. This one right here. Okay. Well, this is just a bunch of little stars and dots right there. Okay. So since this is not a function or a graph like this, we don't need to necessarily use any of our inequalities. Okay. We're just going to go ahead and simply state the coordinate of each point. Okay. A right here, I just labeled them A through G. Okay. A is negative 6, 3. So negative 6 for the domain, negative 3 for the range. And I went ahead and put all the points for each of them. Okay. So go ahead and take a moment to check if I've done this right. for each of the points. And that's A, B, C, D, E, F, and G. Okay. Now, we've checked our domain. Again, it's all the x values. Check the range, it's all the y values. Now, is this a function or a relation? Okay. Again, we can use, because it's on the graph, we can go ahead and use our vertical line test. Make sure you keep the ruler straight. I only hit 1 point, 1 point, 1 point. Oh, look at that. I hit 2 points at this, 1 point, 1 point, but it doesn't matter. As long as I hit more than 1 point at anywhere in this entire thing, this becomes a relation and no longer a function. Okay. Now, last thing that we have here, okay, it's a U-shaped graph going down. Okay. Again, we start off with how far to the left and how far to the right. Okay. Well, this arrow says it keeps going this way, and eventually, because it's slanted, okay, it's going to go forever to infinity this way and forever for infinity this way. So that means we can put in any number we want for the x value, and we'll get some y value. Okay. So we can say domain is all real numbers. Well, now let's talk about the range. How far down does it go? Well, the arrows keep pointing down forever, so that means it goes down forever. But how high does it go then? Well, it stops at, okay, the vertex of this thing is at 5. So we can say y is less than or equal to 5, because it's all values are less than or equal to the number 5. Okay. Again, we can do our quick little vertical line test to see if it's a function or a relation. And we go across, and look at that. Hitting only 1 point at all times, this is a function. Okay, and that's it for Unit 3, Lesson 2.